Welcome from Geneva, Switzerland. This is Reda Sadki, and this is week 2. This is a special session dedicated to coverage survey sample size calculations. Very pleased to welcome Dale Rhoda today. So he will be our guide. The entire session will be dedicated to his presentation, discussion, examples, dialogue with him. Before handing it over to Dale, of course, I'd like to ask Carolina Danavaro to say a word of introduction.
Hello, everybody. Am I unmuted? Okay, hi. Welcome to this session. It's a special session for sample size calculation with Dale Rhoda, who was one of the co-authors of the WHO Vaccination Coverage Survey Reference Manual. And the presentation will be available, same with the Excel. If you have any questions, you can type and we'll try to answer them. And also any issues you may have, you're always free to contact us. The best way is through a message in the Scholar. Thank you.
Great, thank you, Carolina. So yes, you are definitely encouraged to type questions and comments while Dale is talking. This is actually allowed and encouraged in this context. It's one of the benefits of using a technology like this. So Dale, over to you. There have been already some people, a few people may have already seen some of the updates in which you presented a little bit of background and some of the steps involved in the coverage sample size calculations, but let's start from scratch today. Very much looking forward to your session, and over to you.
Thank you, Reda. Welcome, everyone. Thanks for taking time to join us today. I value your time and hope you'll feel it was well used. As we mentioned a few minutes ago, if you have questions, we'll be looking at them in real time and try to address them as they come up, although my attention might be, sometimes I may be so focused on what I'm saying that I miss your question in real time. So we'll have some additional time at the end. You could repeat your question if I didn't get to it, and I will also review the log of what's in the chat window, and if there's something that we missed today, then perhaps we can touch on it briefly tomorrow. So don't have your feelings hurt if I don't address it in real time. I'm new at this level or this method of multitasking, so it's not personal if I miss your question in real time. So I know that you have some materials that have been posted with links to some YouTube videos, a series of 9 videos to walk you through this, and we're going to be looking today at some of the slides that you see in the videos. So this presentation today will mirror or copy or reinforce some of what's in the videos. Don't worry if you haven't had time to look at the videos yet. If you're seeing this material for the first time today during the briefing, then this will be your first exposure to my way, anyway, of presenting this material and this vocabulary, and then it will be reinforced when you watch the videos. If you have already watched the videos, then you'll be seeing some slides that are familiar, and then we'll do a deeper dive into the Burkina Faso slides. So the first set of slides will be familiar and from the videos, and then the specific examples of sample size calculations today will be some new slides, and we'll get to do some calculations, and we'll use the Excel tool together. We've already had some nice feedback this morning on WhatsApp to say that at least one of my instructions from the videos did not work for the student, because when I used the spreadsheet, I used an unlocked version, and what we have provided to you is a locked version. So we'll use a workaround today to make sure we can come to the same place, and then we'll work on maybe posting a version where the cells that I suggest that you use, that they are unlocked. The big picture. Let's see, before we get started, I'm going to skip some of the slides that are in the videos to incent you to to watch the videos. So we'll skip the car slides, but this is a figure from the first part of the manual where it talks about the stage of survey planning that I believe we're in for Harmonia. Or I saw that some of your spell checkers this week, in WhatsApp anyway, some of your phones were correcting the spelling of Harmonia and calling it harmonica, which I thought was very funny. So in Harmonia, we're in this stage where we're trying to decide whether to do a survey and what should we measure. And very early in the process, we calculate a sample size because we want to allow the steering committee to estimate the budget and the timeline for the proposed survey so they can decide, is what we're thinking of doing, is it affordable, and can we do it in a timely manner? And it's often the case that the first thing that people request, that the answer is no, and so we have to go back up the loop and revise the primary question or some parameters of the goals and revise the sample size. And we go through this loop until we either decide, golly, nothing that we can afford will be helpful, or we identify a design that will give us some programmatic insight and that we can afford, in which case we drop out of the loop and we move on to survey planning. So that's the context of why we're talking about sample size so early in the course. I want to give credit where credit is due. And so this is a photo of the four of us who wrote the current draft of the WHO manual. And these ideas didn't just spring forth from my brain. They're the product of long conversations with these fine folks. So this is the writing team who drafted the current version of the manual. Tony Burton on the left, that's me in the middle, Pierre, and Felicity. And so it was a pleasure and honor. It is a pleasure and honor to work with these people. And a lot of the ideas I'll discuss today came from conversations with them. And then, as I said in the video, this is my colleague, Mary Pryor, who works with me here in Ohio. And Mary is the primary author of Annex B in the manual. And if you haven't dug into Annex B yet, most of the material that you'll need to do your homework and that we'll be discussing today is in the first part of Annex B. Annex B is broken into 3 parts, B1, B2, and B3. And it's B1 really that we're focusing on this week. And so Mary's the one who's created these tables and created the worksheets for doing the calculations in using a paper and pencil or a paper and a calculator. And then we'll also use the Excel tool, which was created by Dana Thompson, pictured here, who took Mary's paper-based process and pulled it into Excel. And we've run a number of scenarios through both the paper and pencil and the Excel, and they're giving the same answer or the same answer to within a person or two in the sample size calculations. We feel confident that for the exercises this week, the Excel tool is going to give you the answers that you need if you'd like to do it that way, or if you'd like to do it using paper and pencil and then check your answers using Dana's spreadsheet, that will be great. So in our time together, I will show you examples of both. The overview of, perhaps this is familiar to all of you, but when we're going to do a survey, when we're finished, when we have an estimate of vaccination coverage, it's an estimate maybe to give to the Minister of Health or the person in charge of the vaccination program, that estimate will have a margin of error because we didn't speak to all of the kids in the country. We sampled some of them. And if we had sampled a different group of kids, then we would obtain perhaps a slightly different estimate. And so the amount by which our estimate could vary if we took a different sample, we'll call it the margin of error here. And the margin of error is related to the sample size. If you interview more kids and more caretakers, then you can get a more precise answer. But and getting the first bits of precision is quite easy. You can get some precision with a fairly modest sample size. But to squeeze out, to drive the margin of error down below, plus or minus 5% or plus or minus 3%, it requires a substantial increase in the survey budget and logistics. And so what we want to do in selecting a sample size is find a sample size that meets the needs of the survey consumers, gives them an answer that is as precise as they need, but maybe not more precise than they need. When we describe the margin of error in an English language sentence in the report, we usually use a confidence interval. We usually use a 95% confidence interval. So it might be reported like this to say, we estimate that 92% of the kids are vaccinated, and the 95% confidence interval might extend from, say, 88 to 94%. And then we could also use the sentence to say that we are 95% confident that somewhere between 88 and 94% of the target population is vaccinated. So the big picture here is we want to select a primary outcome for the survey. That's the job of the steering committee, although sometimes we have to guide them in that process. It's often coverage of Penta 3, of the third dose of pentavalent vaccine, is often the primary outcome. And then for that primary outcome, we need to understand what margin of error is available. And then we use some tables to look up what number of respondents we would need to provide that margin of error if we were doing a simple random sample. But we're not doing a simple random sample. We're doing a cluster sample for reasons of economy. And so we have to take the number that we calculate in step 2 and we have to inflate it. We have to increase it for several different factors. And so this process that we'll describe today, the 6-step process of gathering together the numbers, the inputs, to calculate this, to do, I guess, what we've called step 2 and step 3 here, we have a 6-step process to accomplish these steps. And here's the same thing said graphically. We get some inputs. Some of them have to do with our survey goals, our margin of error, what level of error would be acceptable. Some of them have to do with the factors that will likely widen that confidence interval, or that might decrease the number of completed responses. And then we look up some tables, or we run some numbers through equations to calculate an effective sample size. That's how many kids would we need to interview if we were doing a simple random sample. And then what are all the inflation factors? And we multiply those together. And then we have some numbers that the budgeting team can use, like how many clusters will we have to send teams to? When the teams get to those clusters, how many households will they need to visit? And what's our target number of respondents from each cluster and from the whole overall survey? And the budgeting team and the logistics team will look at that and come back with some numbers to say what they think it would take to accomplish those goals. We'll talk about the longer names for these, but we have a shorthand in our worksheets for the quantities that go into our calculations. And so we call them A, B, C, D, E, and little m. And we work with the committee to gather those inputs. And then we use the inputs to look up or calculate the 6 values, and then we multiply and divide them together in equations that are listed in your worksheet in Annex B1. That's the big picture of what we're doing. I'm going to skip over estimation versus classification for now. Maybe we'll come back to it. And if we have time for questions at the end, maybe we'll talk about it some more. Mostly we'll begin the discussion with the goal of estimating coverage. So we want to provide an estimate with a specified margin of error. Here are the quantities that we need to assemble that go into the sample size calculation. And I'm going to talk about each of them in some detail, so I won't linger too long on this slide. These are the quantities that we call A, B, C, D, E, and M. And that nomenclature, the A through E and M, that's unique, that's specific to this manual. The first quantity is we have to decide how many places are we doing the study. Where do we need representative results? And so we might be doing it at the national level. We might be doing it at subnational, at regional levels. So in Burkina Faso is one country with 13 regions, 63 health districts. Are we doing just one survey and we'll produce results only that are at the national level with no detail about the portions of the country that are doing better or worse? Or will we drill down and do maybe 13 surveys, one in each region, or maybe 63 surveys, one in each health district, and provide representative results at each of those levels? And there's a video that goes into more detail on that. So here's a map of Burkina Faso. Here are the 13 regions. There's no labels here, but you can see these are the administrative regions. And then we can fill in the boundaries of the health districts. Here are the 63 health districts, and they are nested within the administrative regions. And so we'll have to talk with the survey committee and see where do they want 1 result, 13 results, or 63 results. The second factor is the effective sample size. That's the sample size you would need to use if you did a simple random sample. There's a whole separate video on this item here. Here we're going to ask the committee, what's the primary outcome of interest? What do you expect the coverage outcome to be? Seems a little funny to ask them to guess what the survey results will be. And then how much precision do you need? What's the widest confidence interval that would still be useful to you? So their answer might look like this. They might say that if it's a post-campaign survey, they might say the primary outcome is the coverage that was achieved in this supplemental immunization activity. The target is 95% coverage, and we would like to have a confidence interval no wider than plus or minus 5%. Well, once you have that information, you turn to table B1, and you're in Annex B1. There's a column here for 95%. There's a column for precision of plus or minus 5%, and that tells us that the effective sample size would be 162. And so we would consider that to be quantity B. The next, and there are different inputs if it's for classification, then there are a few additional inputs. Again, we'll talk about those in some detail. There's a video that talks about them in detail. The next input is one of the inflation factors of the design effect. How much do we need to increase the sample size because we're doing a simple random sample, because we're doing a cluster sample instead of a simple random sample. And for design effect, we have a couple of inputs. How many, little m, how many respondents do we expect to have per cluster? And then something called the ICC, or the intra-cluster correlation coefficient. In a very few cases, you'll have an ICC from an earlier survey, but usually you'll pick the value from Table C in Annex B1, and you'll pick a value for SIA surveys or routine immunization surveys. And then to calculate the design effect, again, we look at the intersection between a row and a column in Table C. We'll do an example of this in just a moment. Quantity D is an inflation factor. How many households are we going to have to go to find that eligible child? So if I'm willing to, if all people are eligible respondents, then every household will have a person that could be eligible in it. But for routine immunization survey, we're often looking at the target population as kids who have had their first birthday, but not yet had their second birthday. And not every household has one of those. Sometimes you might have to go to 3 or 4 or 5 or 6 households to find an eligible child. And having an idea of how many households you have to visit to even find an eligible child, that will help you estimate the workload and the time that will be required to do the survey. And so this is quantity D, and the people who are experienced with doing surveys in the country where you are working, they will be able to either tell you the factor outright, or they can tell you some inputs here, and you can use an equation in Annex B1 to calculate how many households you need to visit to find an eligible child. And the last inflation factor has to do with non-response. Some people will refuse to participate, and some people will not be at home. And so we will have to visit even more homes than we originally thought, because sometimes we will come to a home where there would be an eligible participant, but we cannot get a response from them. And so we have to visit even more homes. And so the last input here is an inflation factor for non-response. Again, the survey professionals with experience in your country will be able to suggest to you probably what will be the level of non-response. And then you can put that in a table. You look up in the table. So if it were 15%, then the inflation factor, quantity E to carry forward, would be 1.18. And then we put those numbers to work. So in Annex B1, you have some worksheets. The first worksheet is on page B111, so you should all have downloaded and maybe printed Annex B1 or have it available on your screen. We'll look at an image of it in a moment. And you write these quantities at the top of the page, and then we have some calculations Very simple calculations on the page. The equations are there. And the equations are programmed into Dana's spreadsheet to calculate the numbers that we need. How many households or how many completed interviews are we hoping to have? How many households do we need to visit to achieve that number of completed responses? How many households will we visit in each stratum? How many households will we visit in each cluster? How many clusters will we visit in each stratum? These are the numbers that we pass on to the budget teams for them to do their job and estimate the budget. So that was a quick overview. Everything I just said is described in more detail in the 9 videos in the link that Rita sent yesterday. I believe it was yesterday. So you can look at those, and if you have questions, post them in the Scholar, and I'll be watching that closely every day this week. We'll try to give answers to those things.